Hello guys, welcome back to my channel. I know it has been a very long time since I've last uploaded. I've been a bit busy, but I know you guys have your exams coming up in a few weeks, so I'll try my best to upload more videos towards that exam. And if there is any video you'd like me to do, make sure to drop it down in the comments below. And for today's video, I'll be going through all the formulas you'll need for IGCSE Physics, and I can guarantee you, if you can memorize all these formulas and understand how and where to use them, you'll be set for physics. So let's start. The first one is in motions. So the first formula is a basic one. Velocity is equals to distance over time. So we can rearrange this formula to find distance too. So distance would be velocity times time. And to find time, it would be distance over velocity. The v could also mean speed. So if it's speed, it's distance over time, and if it's velocity, it's displacement over time. The second formula is for average speed. So average speed is the total distance divided by the total time. So average speed is usually given on speed time distance time graphs. So we can have like a distance time graph. This could be 10, and then we can have like 5 seconds here, and then we can be asked to find the average speed, but then the graph could not be easy. So the average speed would be the total distance, which is 10, over the total time, which is 5. So average speed would be 2 meters per second. That's how we find average speed. The next one is for acceleration. So acceleration is the final velocity minus initial velocity over change in time. This could also be the change in velocity over the change in time. That's the acceleration. The next one we need to look at is motion graphs. So there are different motion graphs and there are different formulas to find distance, velocity, and also acceleration from those graphs. The first one is a distance time graph. So for a distance time graph, the velocity is equals to the gradient. So the gradient is y2 minus y1 over x2 minus x1. So to find the gradient, we can take 2 points from the line, and then we find the x values and the y values. So this could be the x2, this could be x1, this would be y1, and this would be y2. So we just put the coordinates into this formula and we find the gradient, which is also the velocity. The second one is a velocity time graph. So in a velocity time graph, the area gives us the distance. So for example, this is a triangle, a right angle triangle. So if we find this area, that would give us the distance. And to find the area of a triangle, it's half base times height for a right angle triangle. And to find the acceleration is equals to the gradient. So we find the gradient the same way we did like before. We can have 2 points. This could be the x2, this would be y2, and then we have x1, and then y1. So we insert these coordinates into the formula, and then we find the gradient, which is also the acceleration. The next one is also a speed time graph, but then it's a straight horizontal line. So the distance is the area. So this forms a rectangle. So for a rectangle, the area is length times width, or the base times height. So we just multiply the base and the height, or the length and the width, to find the area, which would also give us the distance. Now, the acceleration for this one is going to be 0, because the gradient is 0. Since it's a straight horizontal line, the gradient will always be 0. The last speed time graph is like this one. It has a trapezium shape. So to find the area and to find the distance, first what we can do is we can find the area for the trapezium. So the area for the trapezium is given by half times height times a plus b. So a plus b in this case are the bases of the trapezium. So this is the first base, this is the second base. So we add this two and multiply it by the height. So the height is given by the vertical height. So don't be mistaken and take this slanted line as the height. The height is the vertical height. So the area and the distance in this type of speed time graph would be half times height times a plus b, in which a and b are the two bases. Let's move on to the next one, forces. So the first formula you need to know for force, it's a basic one and very important one, is force equals mass times acceleration. So we can rearrange this formula again to find mass, which is force over acceleration, and we can also find acceleration, which is force over mass. If you're enjoying the video so far, make sure to like and subscribe, and if you want the PDF of these formulas, it would be down in the description below, so make sure to check it out. Now the second formula is for momentum. This stands for momentum, and momentum is mass times velocity. That's the formula you need to know. The next one is for change in momentum. So to find a change in momentum, we find mass times the final velocity minus mass times the initial velocity. That's our change in momentum. But also, we can factorize out the m, and it would be mass times final velocity minus initial velocity. This means mass times change in velocity. That's our change in momentum. Because, as you know, the mass doesn't change. It's the speed of the objects that change. So, we can multiply the mass just by the change in speed. The next one is for force. So the other formula for force is change in momentum over time. So if after we found the change in momentum using the previous formula, we divide it by time, we get the force. The next one is for conservation of momentum. So conservation of the momentum states that the momentum before collision is equal to the momentum after collision in a closed system. So let's say we have two objects. We have m1 going at speed v1, and then we also have m2 going at speed v2. And this collides, m1 collides with m2. So when they collide, let's say after the collision, they stick together. So I have m1 and m2, and they're going at a speed, let's say v prime. So this is what the formula states. The momentum of m1 plus the momentum of m2 is equals to their combined momentum. So after they have collided, their masses join together and they're moving at the same speed. So this is the formula. m1 v1 plus m2 v2 is equals to m1 plus m2 times v1 v prime. So since they have the same speed, we can just add the mass up and multiply it by the velocity. The next one is moments. So moment is force times perpendicular distance. Now I cannot stress this enough. It should always be the perpendicular distance to the force. So let's say we have a beam balance over here with a pivot at this point. So the moment would be the distance from the pivot to the load, and the force is acting downwards. So we can see that these are perpendicular. The distance and the force are perpendicular. So the moment is the force times the perpendicular distance. Now this one is the another formula for moments. So in this formula, we know that the clockwise moment is equals to the anti-clockwise moment. So F1 act downwards and F2 act also downwards. So the moment this side is going to be the distance d2 times F2. But if this object is in equilibrium, that means the anti-clockwise moment is equals to the clockwise moment. So d2 F2 is equals to d1 F1. So this is the anti-clockwise and this is the clockwise. So these two are equal, so their moments are also equal, but also in different direction. Next topic, density and pressure. So the first formula is for density. So density is mass over volume. And when you're calculating density, make sure the units are all in the same. Either it's gram per centimeter cubed or kilogram per meter cubed. The next one is for pressure. So pressure in solids is equals to the force over area. And in liquids, pressure is density times gravity times height. Now, this formula can be derived from the above formula, force over area. So let's see how we can do that. So we know that pressure equals force over area. And we know that force is mass times gravity over area. And from the density formula, we know that density equals mass over volume, right? So we can rearrange this formula to find mass. So mass would be density times volume. So we can put density times volume over here. So our pressure would be density times volume times gravity over the area. And what is the formula for volume? So we know that volume is equals to the area times height. So we put area times height over here. We find pressure equals to density times area times height times gravity over area. So the areas cancel and we have our final formula. Pressure is equals to density times height times gravity, which is this one. But they would likely not ask you to drive the formula, so it was just for your knowledge. The next one, work, energy, and power. So the first formula is work is equals to force times displacement. Now this displacement should be in the same direction as the force. So let's say a box is being pushed this side with a force. So the displacement should be in the same direction as the force. So the displacement should be this side. So work done would be F times D. The next one is for energy. So energy, the first one is kinetic energy. It's half mv squared, half times mass times velocity squared. The second one is potential energy. Potential energy is mass times gravity times height. And potential energy and kinetic energy are equal if there is 100% efficiency or there is no energy wasted. So if there's no energy wasted, that means all the kinetic energy is transformed to potential energy, and all that potential energy is could be transferred to kinetic energy. So if kinetic energy is equals to potential energy, half mv squared equals mgh. And then we can use this formula to answer some questions. The next one, it's about power. So now there are two formulas for power. Power is work done over time or energy transferred over time. So we need to know both these formulas to calculate power. The next one is efficiency. So this symbol represents efficiency. So efficiency is the power outputs over the power inputs times 100%. So the power output is the power given out by a machine. Let's say we have a motor, and I'm very bad at drawing. Wait. Okay. Let's say we have a motor, and then that motor is like turning on a conveyor belt. So this conveyor belt is moving continuously, and it's moving a box. So there's some electrical power generated into the conveyor belt, but then due to like heat, some of energy is released to heat. So this is electrical, and then some is released to heat, some energy, and some of it is used to move this box. So the power output would be the energy released to move the box. That's a power output. But the power input is all the electrical input we have put into the motor. So we multiply by this by 100, we get the efficiency of the machine. Thermal physics. So thermal physics, the formula you need to know is that this is very important. Q equals mc change in T. So Q is the energy, the heat energy, is equals to the mass times specific heat capacity. So C is specific heat capacity. So specific heat capacity is the amount of energy needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. That's specific heat capacity. And don't worry, these values would be given if they ask you to calculate energy, so you don't have to worry about it. And T is the change in temperature. So we subtract the final temperature and the initial temperature to find change in temperature. The next one is conversion between degrees Celsius and Kelvin. So 0 degrees Celsius is 273 Kelvin, and 0 Kelvin is minus 273 degrees Celsius. So to convert between them, so if we have 25 degrees Celsius, we just add 273 to find it in Kelvin. So that would be 298. And to convert from Kelvin, so if you have 298 kelvins, we just subtract 273. We have 25 degrees Celsius. That's how we convert between Kelvin and degrees Celsius. Now, this type of questions have been popular recently, so make sure you know how to convert. The next one, waves. So now for waves, the first formula is speed. So the speed of a wave is frequency over wavelength. So the wavelength of a wave is the distance between two crusts or two troughs. So let's say we have a wave. So this distance between these two is the wavelength. That's the wavelength. So just multiply the frequency times the wavelength. And frequency, the formula for frequency is 1 over t. So now t is the time taken for one complete oscillation. So one complete oscillation means this. Let me just use another color. This is one complete oscillation. From this point to this point. So the time taken for this oscillation is t. So 1 over t, that would give us the frequency. Next one is, so this is a reflected wave. So for reflected wave, angle of incidence is equals to angle of reflection. So these two angles are equal. So you just have to know that. And this is refraction. So for a refracted wave, there's what is called the refractive index. So refractive index is sine r over sine I. That's the formula for refractive index. Now you have to know this formula by heart because they have been coming up a lot in recent papers. The next one is, so this is for total internal reflection, or right before total internal reflection. So if you don't understand this topic, I have gone through it on my waves video, so make sure to check that out. So so this is the critical angle. So the critical angle is the angle between, it's the angle of incidence when the refracted ray is along this line, or along the principal line. If this angle increases anymore, so let's say if it increases, there would be total internal reflection. There would be no refraction. So if we have this angle of this critical angle, then the refractive index would be 1 minus sine c. So you might be asking, where is the 1 coming from? So the refractive index is sine r over sine I, right? So in this case, I is c, so it would be the same, but sine r. So since this refracted ray is along the axis, it's 90 degrees. So sine 90 over sine c. So sine 90 is going to be 1 over sine c. That's where the formula comes from. And the final formula for refractive index is the speed of light in air over the speed of light in a medium. So if we have like, so let's say this is air and this is glass, the speed of light in air over the speed of light in the glass, that would give us refractive index. And the speed of light in air is 8 times 8. There has been a mistake. It should be 3 times 10 to the power of 8 meters per second. That is the speed of light in air. Next topic, electricity and magnetism. So the formula for current. So current is Q over T. This is the charge over time. And the next one is for Ohm's law. So Ohm's law states that the voltage is equals to I times R, the current times the resistance. And we can rearrange this formula to find I. So I would be V over R, and R would be V over I. Now the next one is for power. So we know that power is I times V, the current times voltage. Now there's another formula for power, which is I squared R. But this formula is derived from this one. How? I'll show you. So power equals IV, and we know that V is IR from this formula. So if V is IR, that means it would be I times IR. So that would be I squared R. So this formula is very useful if they've only given us the current and the resistance. We wouldn't have to find the voltage to find the power. It's like a shortcut. The next one is energy, electrical energy. So electrical energy is IVT, the current times voltage times time. Now EMF. So EMF is the electrical energy generated per unit charge, and it's measured in volts. Potential difference. Potential difference is very closely almost the same as electrical energy, but there's a slight difference. So potential difference is electrical energy supplied per unit charge. So the difference over here, supplied and generated. So I'll explain the difference. This is also measured in volts. So let's say we have this circuit, and there we have a battery generating generating electrical energy. So the EMF is the voltage of the battery, in simple words, and potential difference is the voltage from supply, the voltage from like a component. So let's say you have a lamp here. So the potential difference is the voltage supplied to the lamp. And EMF is the voltage generated from the battery. Now you see the difference, right? EMF is the one generated by the battery. PD is the one supplied to a component. That's the slight difference. Now this one is for a transformer. So VP represents the voltage in the primary coil, and VS is the voltage in the secondary coil, which is equals to the number of turns in the primary coil over number of turns in the secondary one. So if we have a transformer, let's say, we have like, this is the primary one, so we have some coil. Let me just redraw that. That was a horrible drawing. Wait. So this is a number of primary coils, and then we have the primary voltage, and we also have the number of turns in the secondary coil. So if the number of turns in the secondary coil is greater, that means Vs would be greater too. So let's say if the voltage in the primary coil is like 3 volts, and the number of primary coils, the number of coils in the primary, that would be 1, 2, let's say it's 10. So if NP is 10, so the number of turns in the secondary coil, let's say that one is 20. So we use the formula. So Vp over Vs. So Vp is 3 volts. We don't know Vs. Np is 10. And Ns is 20. So we can just solve this. So we cross multiply. So it would be 20 times 3 over 10. That would give us Vs. So Vs would be 6 volts. So since the number of coils increased, the voltage also increases, and also the vice versa. The next one is IP Vp is equals to Is Vs. So this is also transformer calculation. The current in the primary coil is times the voltage in the primary coil equals to current in the secondary coil times voltage in the secondary coil. That is if the transformer is 100% efficient. Otherwise, some energy might be lost to heat, so they will not be equal. So this also means the power in the primary coil is equals to the power in the secondary coil. Next topic, nuclear physics. So in nuclear physics, we have to know the charges of the proton, neutron, and electrons. So proton is a +1, neutron is 0, and electron is a -1. And proton and neutron have a mass of 1, but electron, it has a mass of 1 over 2000, or sometimes you can also just make it 0 because it's too small, so it's negligible. Next one, alpha decay. So alpha decay is a type of decay, and we just have to know the equations. So in an alpha decay, let's say we have a nucleus with M. So this is a mass number, and this is atomic number. So in alpha decay, the mass number after an alpha decay, there is going to be an alpha particle released. So this alpha particle has a mass number of 4 and atomic number of 2. So in any equation, the mass number on one side should be equals to the mass number on the other side, the total mass number. So the new nucleus formed is going to have a mass number -4 and an atomic number -2, because 4 of the mass numbers has went here in a sense, and the 2 of it is over here. So if we add these two together, this y and alpha particle together, we'd get the mass number of x and atomic number of x. And for a beta minus decay, we have the same one, x with mass number m and atomic number z. So the particle formed, a beta particle would be released, and it has a mass number of 0, and it has a charge of -1. So for us to balance this, if we have z plus 1, the atomic number would increase by 1, but the mass number would stay the same. That's for an alpha particle. I mean a beta decay. And for a gamma decay, we understand that gamma is electromagnetic wave, so it has no charge and it has no mass. So the gamma particle released is going to be 0, 0, so the mass is going to be the same. And the atomic number is also the same, nothing changes. These are the 3 decay equations. And now these equations are very popular, especially in multiple choice, so make sure to know them. Next one, space physics. So for space physics, the orbital speed is 2 pi r over t. Now I'll explain this formula. So we know that speed is distance over time, right? So for orbital speed, let's say we have the sun and we have one planet. Now this is, let's say the planet is orbiting around the sun. So this forms a circle. So the distance from the center of the sun to the planet is r. That's the radius of the circle that forms. So the distance traveled is going to be the circumference of a circle. So circumference is going to be 2 pi r. So the distance is 2 pi r, and the time taken, that's just t. So the speed is 2 pi r over t. That's how we got this orbital speed formula. The next one is Hubble's constant. So Hubble's constant is v over d, the velocity over the distance. So v is the speed at which a galaxy is moving away from Earth, and d is the distance from the Earth. So the current distance of that galaxy from Earth. And the Hubble's constant has a certain value. It is 2.2 times 10 to the power of 18 per second. So the unit is not second, it's second to the power of -1. So what's interesting is we can use the Hubble's constant to find the age of the universe. So Hubble's constant is 1 over ho, right? And since it's 1 over second to the power of -1, that would just give us seconds. So 1 over 2.2 times 10 to the power of -18. This would give us the age of the universe in seconds. So this interesting formula can give us the age of the universe. And that was the last formula you needed to know. And that's it for this video. I hope you have enjoyed this video. So make sure to like and subscribe for any upcoming content. So I'll try my best to be posting videos right before exams. So make sure to stay tuned, and thank you for watching.